Hi, everybody. Welcome to topic 29. In this topic, I'm going to introduce what is so-called the hypothesis testing. So far, or lately in the last few topics, we talk about taking lots of samples, and those samples become a random variable. So sampling distribution of a sample mean or sampling proportion we talk about, so again, when we talk about those taking those lots of samples, that refer back to what we learned on topic number one, which is basically saying that, it's almost impossible to, to find the true population mean. So instead, we're taking lots and lots and lots of samples, right? And then, we talk a little bit about how to estimate the true population mean based on the point estimate, which is our sampling, which is our mean of the sampling distribution, okay, X bar. So we talk a little bit about estimating the population mean, population proportion. So now in this particular topic, we're going to take a look at testing what they say. Okay, a lot of when we read newspaper or TV, people throw a lot of statistical data at us. So this is actually a way to test whether those numbers they are they are telling us whether they are true or not true, kind of like. Okay, so a hypothesis is a statement regarding a characteristic of one or more populations. Okay, what is so-called a null hypothesis, which is denoted as H null, or like a 0 or O. A null hypothesis is a statement regarding the value of the population parameter, mean standard deviation, and and the mean standard deviation and population proportion. That is to be tested. Null hypothesis is a statement regarding the value of population parameter that is to be tested and always contains the equal sign. Okay, so null hypothesis is what they say. The alternative hypothesis, which is called H alternative, is a statement regarding the value of the population parameter that we are trying to find evidence to support. Okay, so we are testing whether what they are saying is true or not true. So we are the alternative. They are the null hypothesis. Okay, a test statistic is a value represent the number of standard deviation that the sample mean is from the assumed mean, called Musa null. Okay, that's a Musa null. So that's the mean, that's the assumed population mean. So that's assumed what they are saying. Oh, this can be a Pisa null, right? Population, it can be a population proportion of what they say. All right, here's a fact, okay? We never accept what they say, the null hypothesis. We never accept what they are saying is true. Instead, what we say is we fail to reject the null hypothesis. We fail to reject what they say because we cannot find the evidence to support our claim. All right. So there are three ways to set up the hypothesis. We can have a two-tailed test. We can have a left-tailed test. We can have a right-tailed test. Okay, there are three type of way we can set it up. So for every test, you're gonna write out your null hypothesis and your alternative hypothesis. Whatever the parameter is, whether it's a population mean, whether it is population proportion, okay, it will equal to some value that they are saying. For two-tailed test, will always be not equal to. Okay, null hypothesis always contain the equal sign, but two-tailed test we are saying not equal to. A left-tailed test, the alternative will be less than. Right-tailed test, the alternative will be set up as the parameter greater than. But the null hypothesis is always contains equal sign. Okay, so here is an example. I'm going to state the null and alternative hypothesis. So here it says a sample of 900 computer chips revealed that 58% of the chips fail in the first 1,000 hours of their use. Okay, so this is a sample of 900. So this 58% come from this sample. The company's promotional literature claimed that 62% fail in the first 1,000 of their use. Is there sufficient evidence at the 0.01 level of significance to dispute the company's claim? So the company's claim is the null hypothesis. So this is about percentage. So this is about population proportion. So population proportion, what they are saying is 62%. So that's 0.62. All right. Null hypothesis always contains an equal sign. Alternative hypothesis, what we are saying is there enough sufficient evidence to dispute, which is not equal to 62%. Okay, so that's how we state the null and the alternative hypothesis. All right, here's another example. A manufacturer of chocolate chips would like to know whether its bag filling machine works correctly at the 440 gram setting. Is there sufficient evidence at the 0.02 level of significance that the bags are underfilled? Okay, so this word underfilled. So the underfill will be less than. So the null hypothesis. So this is a mean. The 440 gram second is the mean. So they are claiming is bagging at 440 gram. Okay, but what we are saying, the alternative thing is, is there evidence? Is there sufficient evidence to show that the bags are underfilled? So we are saying the mean is less than 440. Okay, so that's how we state the null and alternative hypothesis. Now, when we start doing the examples, okay, I'm going to show you how to actually state the conclusion. So far, I just kind of show you what hypothesis testing is, what is null and alternative hypothesis, and how we actually write them out. How do we actually write out the hypothesis? Now, this thing called the type 1 and type 2 error, okay, very important. A type 1 error, okay, occurs when we actually reject the null hypothesis, when in reality, the null hypothesis is true, okay? So here's a reality on top, on the left here is a conclusion. If the null is true and we do not reject, then that's a correct conclusion. However, if the null hypothesis is true, but we still reject it, that's called a type 1 error. So here you can see type 2 error occurs when we do not, sorry, there's a word "we" in there, when we do not reject the null hypothesis, when in reality, the alternative hypothesis is true. Okay, that would be called a type 2 error. All right, this thing called the level of significance, which is alpha. So we've been looking at this alpha thing for a while. Z sub alpha, when I first introduced it a while ago, was referring to the area to the right of the z-score, right? And then we also use alpha for the critical value. Here in the hypothesis, under the hypothesis testing, alpha is called the level of significance. It's a probability of making type 1 error and is chosen before the sample data are collected. Okay, so the level of significance is about the probability of making the type 1 error. So type 1 error is, this is very specific. It is saying that if the null hypothesis is true and we still reject it, then that's a type 1 error. Okay, so the level of significance is basically, the smaller it is, that means less chance we are making, less probability we're making that type 1 error. Okay, here's a quick note. As the probability of a type 1 error increases, okay, if the type 1 error increases, the chance of getting increase, then type 2 error will decrease. All right, so I know this is I know this video is there's a lot of examples and with a lot of steps, so I'm going to make this video into two parts. Okay, so I want to at least show you how to do one problem with the hypothesis testing for the population mean, where the sigma is known, where the population standard deviation is known. All right, there are two approaches to the hypothesis testing. The first one is called a classical approach, which we're going to use the critical value and using the critical region. Sorry, this is kind of hard to see. Right here, this is actually negative Z sub alpha. Okay. A right tail, okay, that's actually Z sub alpha. So if our test statistic fall into the rejection region, right, either whether it's a left tail or right tail test, then we will reject the null hypothesis. If it doesn't fall in there, then we fail to reject. So this is a two-tail test, right? So this is a critical value, negative Z sub alpha over 2, and this one is positive Z sub alpha over 2. All right, so this is a classical approach. We're using test statistics and using the critical value to determine whether we will reject or fail to reject the null hypothesis. Another one is called the p-value approach. A p-value is the probability of the critical region. So it's looking at the areas under the curve approach. If the p-value is less than the level of significance alpha, then we will reject the null hypothesis. So right here for the two-tail test, okay, this is actually negative absolute value of a Z sub null. This is positive Z sub null. Okay, these are Z sub null. So I don't think this is negative Z sub null, positive Z sub null. I don't think I will show you how to use this approach because I normally like to show students how to do the classical approach. It's a little bit easier to it's a little bit easier, you know, especially even graphically, it's a little bit easier to understand. All right. So hypothesis testing has certain criteria. Gotta make sure it's a simple random sampling. There's no outliers. Population is normally distributed. Sample size need to be greater than equal to 30. All right. So here are the basic steps. Okay. We got to be able to determine the null and alternative hypothesis. And we also need to know whether it's a right tail, left tail, or two-tail test. Okay, normally the level of significance alpha is already it's already tell us, the problem already tell us what the level of significant alpha is. Now we got to do a little bit of work to find the test statistic. These are the numbers that we're going to test. These are Z sub null. So if I go back up here, okay, Z sub null is the number we're going to test. The critical value is the Z sub alpha, negative Z sub alpha. That's the critical value we're going to find. So once I find the test statistic, whether it's a sigma known, sigma unknown, which is using t value, which is trying to find, which will actually find this t value. Okay. Or population, this is for population proportion. All right. Or this is called a chi-square. This is another one called chi-square. I have not introduced chi-square at all. Chi-square is basically hypothesis testing, which is testing the population standard deviation. Okay, so we kind of skip over that throughout this course, but I do want to kind of write it down. This is called a chi-square, which is another type of distribution. All right, find the critical value Z sub alpha or Z sub alpha over 2 depends on the test, whether it's a left tail, right tail, or two-tail test. All right, then we're gonna compare the critical value versus the test statistic. Okay, so this is what I wrote down earlier. Okay, depends on where the critical value falls. Does it fall, does it fall to the left side of the critical value? Does it fall on the right side of critical value? Or does it fall, to the left or to the right of the two-tailed test? It depends on where it falls. If it does fall into those regions, it's called a critical region or a rejection region, then we will reject the null hypothesis. Okay, if it falls anywhere else, then we fail to reject. Okay, so that's basically what this picture is trying to show. Okay, so I'm gonna do at least this one example, and in the next video, part 2, we'll do other ones too. We'll do the hypothesis testing for population proportion and for the and we'll do one where sigma is unknown. So this example says a manufacturer of potato chips would like to know whether its bag filling machine was correctly at 444 gram setting. It is believed that the machine is underfilling the bag, right? Somebody, somebody's saying that. Somebody says I think it's underfilling the bags. Okay, my chip is not as much. So a 39 bag sample had a mean of 436 grams. Okay, so we took a sample and the mean of those 39 sample only shows 436. Assuming the population standard deviation is known to be 19, is there sufficient evidence that the 0.01 level that the bags are underfilled? Okay, so we are trying to see if we have enough evidence to show the bags are underfilled. Okay, based on all the givens. So number one, list a population mean. So the population mean, which is mu sub null, right? This is what they are saying. They're saying is the mean is at 444 gram setting. Population standard deviation is 19. Sample mean, X bar, the other 39 bag, simple mean shows only we are filling at 436 gram. All right, sample size, N is 39, which is more than 30, so that's good. And the level of significance is set at 0.01. So 0.01 is almost like saying 1% chance. We're gonna give we're gonna say 1% chance making the type 1 error. All right, number two, state the null and alternative hypothesis. So the null hypothesis is what they say. They're saying the bags are set at 444 gram, but we are saying the mean is actually underfill. So that will be a less than. Okay, underfill is less than. All right, so that's your null and your alternative. All right, specify the test is a left tail, right tail, or two tail test. So we are saying it's less than 444. So we are saying this is a left tail test. All right, write down the computation for the test statistics. So I would just basically copy this down right here. This is your test statistic, which we know what the sigma is. So Z sub null is equal to X bar minus the mu sub null, the population, the null hypothesis, the null of the mean, divided by sigma over square root of n. All right, so that's 436 minus 444 divided by 19 over square root of 39. All right, from the answer we get number 4, find the actual value of the test statistics. So let's see what our Z sub null is. We're on to 2 decimal place. So let's put this thing in the calculator. I want the calculator to do the top for me first. So I put that in the parenthesis, 436 minus 444 divided by, okay, the bottom, I want the bottom it to be in a parenthesis because it got division and the square roots. So divided by 19 over square root of 39. I'm gonna close the parenthesis for my square root and close the parenthesis for my denominator. Okay, so that's about negative 2.63. Okay, find the critical values for the rejection region. So what's my critical values? My critical values is my Z sub alpha. So since this is a left tail test, that will be Z sub alpha, which is 0.01. Okay, so the 0.01 will be the area to the left, right? Because I'm using a left tail test, so that'll be area to the left. So let me come down here a little bit. So right now we're doing a left tail test. So this is my negative Z sub alpha. And this is a rejection region right here. Okay. Or my critical region. So let's see what this So the area in here is 0.01. So to find the critical value, we will use inverse norm. Area to the left is 0.01, comma 0, comma 1. So that would be about negative 2.33. So basically this number, the critical value here, that's what we call them critical values. This is negative 2.33. My test statistics is negative 2.63. Negative 2.63 is actually within the rejection region. Negative 2.63. So this is not a, this is actually not a, this is not an area. This is saying that negative 2.63 is to the left side of negative 2.33, the critical value. So if you're to the left of it for a left tail, you are actually fall into the rejection region. So we will actually reject the null hypothesis. Okay, so I've typed this out to kind of give you an to kind of show you how you're supposed to write it. So on the homework, you actually type it out yourself. Okay, I don't give a choice. So since we're rejecting the null hypothesis, then the conclusion will be there is sufficient evidence at 0.01 level of significance that the bags are underfilled. So we did find sufficient evidence to show that the bags are underfilled. Okay. All right. So in the part 2, I'm gonna do this particular example. Okay, then I will show you how to do the hypothesis testing for the sigma unknown and the population proportion. All right, stay tuned.